Good morning, everybody. Today we are going to wrap up the week of comparing fractions by reviewing the topics that we've discussed throughout the week and then finishing up a couple worksheets where you will have to compare all the different types of fractions that we've discussed. Okay, so very quickly to review, we talked about the different types of picture representations that fractions can be seen as. We can have shapes, number lines, fraction bars. These are not the only ways that fractions can be represented. Fractions can be represented as a set of numbers. So if you look down here, if we looked at this not as a fraction bar, but if we looked at this as 4 objects, okay, one of those objects is 1/4. Again, remember when you're comparing fractions, the objects have to be the same size, same shape, they have to be identical. Like when we saw here, we see all these circles along the bottom are equal to each other, okay? Now, we discussed fractions equal to 1/2, okay? Think of your doubles, think of your 2 times tables. We have 1 out of 2, okay? 1 plus 1 is 2, so 1/2 is 1/2, okay? 2/4, 2 plus 2 is 4, so 2/4 is half. 3 is half of 6, 3/6, 4/8. This goes on, 5/10, 6/12, 7/14, 8/16. You could say 50/100ths. You could say 500 1,000ths. You could say 500,000 1,000,000ths. Okay, they're all equal to 1/2. When we order unit fractions, okay, unit fractions are the same rule as comparing fractions with the same numerator because they do have the same numerator. The numerators are 1. So when you're comparing unit fractions with the same numerator of 1, as the denominator increases, the fraction decreases in size. So it's inverted. It's an inverse of each other. It's opposite. So as you can see, 1 out of 1, 1 whole, okay, is equal to 1 whole. 1 out of 2, 1/2. Okay, we see that that denominator increases to 2. It gets smaller. 1/3 is even smaller. 1/4 is even smaller. 1/5 and 1/6, and this would keep going. 1/7, 1/8, 1/9, 1/10. It would just keep getting smaller and smaller as that denominator increases. So it's the same rule as fractions of the same numerator. And here were the examples we did. It looks like, oh, maybe we didn't do this one here. Okay, so let's just do this real quick. 1/2 and 1/3, okay? We see the numerators of 1 are the same. We are comparing unit fractions. So since 2 is smaller than 3, that means it's divided into less parts. That means that one of the parts is bigger. So 1/3 is greater. 1/2 is greater than 1/3. Same thing here. If you look at these really quickly, if you don't think of the rule, you see 4 and you see 5. You'd say 4 is bigger than 5. 4 is smaller than 5. But that's not the case. 1/4, because the numerators are both 1, then we have to, like yesterday's lesson, look at the smaller denominator, and that is actually the bigger fraction. So 1/4 is greater than 1/5. Same thing can be said here. Okay, we have 1/4 and we have 1/6. The numerators are the same. We have 1 and 1. So then we look at the denominators and we compare them, but we're not looking for the bigger denominator. We're looking for the smaller denominator, which will actually be the bigger fraction. So 1/4 is greater than 1/6. And also 1/6 is greater than 1/10. And the picture representations help you to see that. And this especially helps you to see that, okay? As the denominator increases, the fraction decreases. It gets smaller. And this also helps to explain why fractions of like numerators follow this rule as well. So let's go to that next. Fractions with like numerators. Okay, we said that when the numerators are the same, it is the smaller denominator that's actually bigger. Fourths and sevenths. we can see that 3 out of 4 is bigger than 3 out of 7, okay? Here are the examples we did. 2/3 is greater than 2/6, as you can see by the picture representation. In fact, 2/6 is equal to only 1/3, and you can see that here. And 4/5 is greater than 4/9. Okay, now let's go back to comparing fractions with like denominators. This is the easiest of them all, the easiest to understand at least. When the denominators are the same, you're comparing basically the same two shapes. So look here, this circle with 5 and this circle with 5 are exactly the same shape. So simply, the one that has more shaded in is bigger. We can see here 2/5 is less than 4/5, and the same can be said here. 2/8 is less than 5/8. Okay, because you're really comparing absolutely identical divisions of the shapes. With like numerators, you're not comparing the shapes are not divided exactly the same. They're the same shape, but they're divided differently. With like denominators, not only are they the same shape, but they're also divided exactly the same. So I believe that's about it for your review today, okay? I don't think there was anything else I wanted to say. Again, when you're looking at like numerators, it's the same shape, but they're not divided the same. Like denominators, they are divided the same. And with unit fractions, this is just a great visual for you to see. As that denominator increases in size, that means we're dividing it into more parts. So of course, one of those parts is going to be different. It's the same number line divided differently. So for today, you're going to work on this, okay? You see the question mark? You can click right after it. You'll see a text box, backspace out of that question mark, and type in your greater than, less than, or equal to, okay? If you look at the first row, you should see something similar about all these. They're all comparing your unit fractions. Then here, we're comparing fractions with the same numerator. Follow the rule. It's actually sort of backwards thinking. And then the easiest of these examples here, okay, we're comparing fractions with like denominators, and the same thing here, okay? Follows the same organization of the page. We have unit fractions, we have like numerators, and we have like denominators. Now, of course, in the future with this topic, you're going to see these all mixed up, okay? And we'll get into that next week. All right, but that is it for today. So you'll only see the 2 pages you need to work on today, sort of a short lesson. So please take your time and think of those rules, and we will move on next week past this. Okay, have a great day.